Good morning, sir. My name is K. Pranavi and my roll number is 234G1A0488 and I'm from ECB section. My topic in electronic devices and circuits is halfway rectifier operation, and we'll see in this presentation and learn the applications and what are the ripple factors, efficiencies, all about the half-wave rectifier. So, introduction to half-wave rectifier. The half-wave rectifier is an electronic circuit that allows only half of the AC waveform to pass through. So, as we are seeing in the picture here, so here the AC input is given to this circuit. From this transformer, it is passed through the diode. So this diode only is in forward bias, which takes the only positive cycle and does not allow the negative cycles. So it converts alternating current AC into direct current DC by blocking one half of the input signal. This device is commonly used in low power applications and is simple to construct. So this is the waveform we'll get. So let's see what are the components we use in this half wave rectifier and how the operation works in the half wave rectifier. What are the basic components of the half-wave rectifier? As we are seeing in the picture here, we'll need one diode, a transformer, which is an optional thing, and a load resistor. So here we'll take it will calculate, it will take the signal. So let's see. The main components of a half-wave rectifier include a diode, a load resistor, and a transformer. A diode is responsible for allowing current to flow during one half of the input cycle. The load resistor receives the output voltage and current from rectifier circuit. As we are seeing, the diode is responsible for allowing current to flow one half of the input cycle. Of course, it is in the forward bias, so it only allows the positive cycles and rejects the negative cycle. And the load resistor receives the output voltage and current from the rectifier circuits and displays on the CRO we will connect to it. What is the working principle in this half-wave rectifier? As we are seeing in this circuit here, the signal is AC signal is given. So it goes to the diode, which is in a forward biased. So it takes only the positive cycle of the AC signal and pass through the RL, but the negative cycle is not taken because it is because the reverse is in the reverse pass and it blocks the current, which results in the zero output. So the half-wave rectifier operates by conducting current only during the positive cycles of the AC input. When the input voltage is positive, the diode becomes forward biased and allows flow of the current. During the negative half cycle, the diode is reverse biased and blocks the current, resulting in the zero output. Input and output waveforms. The input waveform is a sine wave that oscillates between positive and negative values. So as we know that AC is a sine wave signal, right? So it actually has a both positive cycle and negative cycle, positive, negative cycle and go on. So the output waveform of a half-wave rectifier is a series of positive half cycles with the negative half cycles clipped off. As you are seeing in this figure below, here only the positive cycles are there. The negative cycle is clipped off by the diode. The resulting waveform is not a pure DC signal. It can be smoothed using the filter techniques. Efficiency of a half-wave rectifier. So the efficiency is defined as a ratio of the DC power output to the AC power input. Typically, the efficiency of the half-wave rectifier is around 40%, that is 40.6%, which means a significant amount of energy is wasted. This low efficiency is due to the fact that only half of the input signal contributes to the output. As we are seeing in this picture beside this matter, here is the given for the half-wave rectifier. Rectifier efficiency is equals to power of DC by power of AC. The formula is given and we'll apply the values, and here we'll get the efficiency value that is approximately equals to the 40%. Ripple factor. The ripple factor is a measure of the AC component present in the output DC signal. As we seen in the output signal, it still has the ripples, that is the curves. So to remove the curves, we use the filter techniques, which we'll see in the class. A half-wave rectifier, the ripple factor is relatively high, indicating more fluctuations in the output voltage. A high ripple factor can lead to inefficiency in DC application, necessitating the use of filtering. So the ripple factor formula is RMS by square root of RMS by IDC whole square minus 1. By substituting the values in this, we'll get 1.21, which is the ripple factor of the half-wave rectifier. Types of half-wave rectifiers, more like what types of rectifier. So what there are two type of rectifier, that is half wave and full wave. In the half wave we use only one diode, and in the full wave we use two diodes. And in full wave again there is a bridge rectifier where we use four diodes. In the half wave only the positive cycle is given in the output section, but in the both are given in both are given. So applications. Half-wave rectifiers are used in power supply circuits for small electronic devices. They are suitable for application where the load does not require continuous DC current. Their simplicity makes them ideal for educational purposes and basic electronic projects. Advantages and disadvantages of half-wave rectifier. The primary advantage of a half-wave rectifier is its simple design and low cost. However, its disadvantages include low efficiency, high ripple factor, and poor voltage regulation. So, of course, the power is wasted, and the ripples are very high compared to the full wave rectifiers, and even the voltage regulation is very poor. These are the disadvantages, and these factors limits its application in high power and precision devices. Conclusion. The half-wave rectifier is a fundamental electronic component for the converting AC to DC. Understanding its operation is crucial for designing basic electronic circuits. Despite its limitation, it remains an important building block in the field of electronics. And in this presentation, it provides a comprehensive overview of a half-wave rectifier and their operations, and what are the advantages and disadvantages, ripple factors, efficiencies. These are the topics we have learned about this in this presentation. Thank you.